Okay, let's continue on. We are in section 1.4. This is the second video. In this section, we're talking about equations of lines, and we're going to take what we learned in that first video and look at some parallel and perpendicular lines. Basically, by the end of this section, you should be able to take two linear equations, and be able to determine whether or not they are parallel or perpendicular. You also might be given one line and be able to write the equation of another line that is parallel or perpendicular. Okay, so let's jump right in and let's talk about, well, let's first just define what parallel and perpendicular mean. So two parallel lines are two lines that no matter how far out in either direction you go, they never cross, they never meet. They stay the same distance apart. So if you measure how far apart they are at one point, and then you move down, either direction, and measure that distance between them, again, it's going to stay the same. Those are two parallel lines. You're probably familiar with that idea. And then perpendicular are two lines that do meet or do cross, and they cross at a right angle or a 90-degree angle. So just to make sure that we understand those terms, and now we're going to look at, okay, if we're given two equations, how do you determine if those two lines are parallel, or if they're perpendicular, or even if they're maybe the same line? That's another possibility, or none of the above. So this first sentence starts out defining two parallel lines. Two non-vertical lines are parallel if and only if they have the same slope and different y-intercepts. So let's just think about that for a minute. So slope we've defined as rise over run. So if I have a line, and if I go from one point to another point on that line, the slope of the line is determined by measuring the rise, or how far up or down you have to go from going from one point to the other. And then the run is how far to the left or the right. So in this case, if I'm starting at this point, the rise would be negative, the run would be positive. So if I want to find a line that is parallel to that goes through, let's say, this point up here, I could start at that point and I could measure that same rise and that same run, and then connect those two dots. And depending on the limitations of my drawing here, that's not too bad. Those two lines will be parallel, and you can, do that with some graph paper. It'll probably look a little bit nicer than mine, but you can see kind of that idea of rise and run. The ratio of those two is the same for two different lines. Now, why do we have to say and different y-intercepts? Okay, so let's just think about that. If we had two lines that have the same slope, if we put that into slope-intercept form, it would be something like y equals 2x plus 5 and y equals 2x. They have the same slope. Different x-intercept, maybe plus 7. Those are two lines that cross the y-axis at 5, and the other one crosses the y-axis at 7. They have the same slope. What if they had the same y-intercept? That would mean that we'd have 2x plus 5 and 2x plus 5. Can you see that those would actually be the same line? So we wouldn't call those parallel lines, because it's the same equation. It's the same. So that's why we put that last part in here that says and different y-intercepts. That's just to rule out that they are the same line. Okay, one other thing about this first sentence that I want to point out is that we said non-vertical. Why did we do that? Why did we throw out the vertical lines before we gave this definition of parallel lines? That's because if you recall, and we're going to deal with vertical lines in the second sentence, if you recall, vertical lines have no slope. When we calculated it, you get something like 4 over 0 or 8 over 0 or negative 2 over 0. It's that 0 in the denominator that's the problem. So these have no slope. So when we look at that first sentence and we said that they're parallel if they have the same slope, well, since the vertical lines don't have a slope, that really doesn't include them. So let's just talk about vertical lines for a minute. If we were in a classroom and I drew a vertical line on the board, and then I handed you the chalk and said, come up to the board and draw a line that is parallel to that, what would your line look like? It would be another vertical line, right? That one's kind of crooked. Pretend like that's nice and straight, right? If you came up to the board to draw a line that's parallel to my vertical line, your line would also be vertical. So this sentence just says that any two vertical lines are parallel. We also have this little thing in here, different x-intercepts, and that's again, just to rule out that they're the same line. If they have the same x-intercept, then they would be the same line. Now, what about horizontal lines? It would also be true to say any two horizontal lines are parallel, as long as the y-intercepts are different. But we don't have to say that. And why is that? Why do we not need a separate sentence for horizontal lines? That's because they have a slope. Their slope is 0. So this first sentence covers them. If two lines both have a slope of 0, they're both horizontal, they're going to be parallel, as long as they're not the same. And that would be that they have the same y-intercept. Okay, so the key here, the thing that you want to remember, you need to remember all these details, but the main thing is parallel, same slope. There's a few little stipulations there that we talked through, but that's the key takeaway here. Perpendicular. Perpendicular lines are two non-vertical. Again, we're throwing those vertical lines out and dealing with them separately since they do not have a slope. And this is another definition that uses slopes. Two non-vertical lines are perpendicular if and only if the product means multiplication, the product of their slopes is -1. So we have our first line, let's call the slope of it m1. And we have the second line, let's call the slope of it m2. If when we multiply those together, we get -1, then we know we have perpendicular lines. Okay? This second sentence is just another way of saying the same thing that's in the first one. I'll explain why after we work through it. Okay, you can also say that the slopes are opposite and reciprocal. So let's break that down. Opposite means if one of them is positive, the other one is negative. Reciprocal means that if you write the first one as a fraction, you're going to flip it upside down, make the numerator the denominator and the denominator the numerator, flip it upside down, and then that is the reciprocal. So if our first slope is, let's just say 3/4. Let's say we have a line whose slope is 3/4. So we'll call that m1. What would be the slope of a line that is perpendicular to that? So I want you to pause the video and I want you to write down the opposite reciprocal of 3/4. Okay, hopefully you paused and wrote. And hopefully what you wrote down is -4/3. There's two things we had to do to go from the first slope to the slope of the perpendicular line. We had to change the sign. 3/4 was positive, so we're changing the sign to negative, and then we are flipping the fraction over. 3/4 becomes 4/3. So these two slopes, if you had two lines where these were the two slopes, you would know these are perpendicular. Let's go back to what we said in that very first sentence, that when we multiply them, we get -1, and let's just check that. So 3/4 times -4/3 equals, so we're taking a positive times a negative, so our answer has to be negative, and we are multiplying, so we can cancel across a negative or across the multiplication sign. So our 3's cancel out and become 1's, the 4's cancel and become 1's. So what are we left with? 1 times 1 on the top, 1 times 1 on the bottom. So that confirms that we get that -1. So two ways to say the same thing. When you multiply the slopes of perpendicular lines, you get a -1, and their slopes are opposite and reciprocal. Okay, just like before, we threw out the vertical lines because vertical lines don't have a slope. But again, I think this is pretty intuitive. If I had a vertical line on the board and I said, come up here and draw a line that is perpendicular to that, I think all of you would come up and draw, unless you were goofing around, you would draw a horizontal line, right? They would meet at a 90-degree angle. And in fact, any vertical line will cross a horizontal line at a 90-degree angle. They're perpendicular to each other because remember, on the plane, they go out indefinitely. So at some point, every vertical line is going to cross, going one direction or the other, a horizontal line. One time, making them perpendicular. Okay, let's do some examples. Now that we have worked through what perpendicular and parallel lines look like as far as the equations, let's put that into practice. So are the two lines, so we're going to be given two lines over here, are these two lines parallel, or are they perpendicular, or are they neither? So what do we need to look at in order to determine this? Well, if we go back to our definitions, we need to look at slope, and we may need to look at at y-intercept, but we definitely need to look at slope. So the easiest way when you're given an equation to look at the slope of a line is to just put it in the form y equals mx plus b. In other words, you're going to solve it for y, and then on the other side, if it's truly a line, you can write the other side as an x term and a constant term. If you can't do that, then you probably don't have a line. You don't have a line. If you can't do that because you've gotten confused or something, then that's one thing. But if it truly cannot be written as y equals mx plus b, it's not a line. So let's look at our first equation. Y equals 4x minus 5. I was real nice to you on this one. Look at that. It's already in slope-intercept form. And so just by looking at it without doing any calculations, we know that our first m, our first slope is 4, and our first y-intercept is -5. Okay, no work needed. We can just visually look at that and know the slope and the y-intercept. But the second equation is not solved for y. It has 4y. Now on the other side, we also have the constant coming before the x term. And really to get that into standard form so we don't get ourselves confused, we want to have our x term and then our constant term at the end. So let's just put this into slope-intercept form. So I'm going to divide by 4, leaving y on the left side. That means I have to divide every term on the right side by 4. I'm also going to change the order. So I have my negative x term, and its coefficient is actually 1. So when I divide by the 4, I get 1/4 x. And then I have plus 8, but dividing by 4, that becomes a 2. So for our second line, the slope, or the m, is -1/4, and the y-intercept is 2. So hopefully you're seeing this. We have two lines that we're comparing. To determine if they're parallel, we check to see if their slopes are the same. We have m equals 4 on the first one, m equals -1/4 for the second. So they are not parallel. Those are not the same. What about perpendicular? We have slope of 4 for the first one. And for the second one, we have -1/4. Look at that. Are those opposite reciprocals? Yes. Keep in mind that 4 is the same as 4 over 1. So when we flip that upside down, we get 1/4. And then, of course, we have to change the sign from a +4 to a -1/4. So those are opposite reciprocals. So the answer is these are perpendicular lines. They are not parallel. So the answer to this question is perpendicular.